Opportunities for third-party innovation with connected car data are constrained by the OEM's dominant role. As the vehicle developer and operator of the vehicle back-end systems that collect the data, the OEM typically has access to all vehicle data. This includes data on vehicle performance, user behavior, and real-time sensor data. While the OEM controls this data flow, access is governed by strict data protection and privacy regulations, ensuring that user consent is obtained and that the data is handled securely and transparently. This regulatory framework aims to protect user privacy, but it also limits the ways in which third parties can access and leverage vehicle data. However, independent automotive aftermarket providers and tech companies, startups, are eager to generate revenue by offering services built on this data. These third parties can innovate by developing applications and services that enhance user experiences, improve vehicle performance, and create new business models. To succeed, they must navigate the complex regulatory landscape and ensure their offerings comply with privacy laws, which present both challenges and significant opportunities for developing new applications and solutions. While Module 2 on connected cars highlighted the exploitation potential of connected car data sharing for OEMs, this module shifts the focus to the opportunities available for third-party service developers. These developers have the chance to leverage shared vehicle data to create and sell innovative data-driven services that cater to a range of user needs. The potential for third-party innovation grows significantly when vehicle data is combined with other contextual data sources, such as weather, traffic, and location data. By integrating these diverse datasets, developers can unlock new possibilities for applications across various industries. The objective of the business use case is to alert the driver to potential hazards on the road ahead by analyzing event data and current weather conditions. The vehicle sends a geospatial key, a unique identifier for the vehicle's location in a specific area, to a driver warning service platform. This platform processes the data to identify potential hazards along the route. The service then returns a list of hazardous events. Using a local risk model, the system assesses the severity of these threats. Based on this evaluation, the driver is either alerted or not, enhancing safety by proactively warning them about potential risks. The driver warning use case is developed by three organizations: Caruso, Virtual Vehicle, and Ubimed. Caruso acts as the data marketplace, providing access to vehicle data and hazard data. Virtual Vehicle VRF contributes by offering additional hazard data, while Ubimed provides critical weather data. The core of the system is the driver warning service platform, which processes all this data to identify potential hazards. In addition to this platform, VIF has developed two key end-user applications: an in-vehicle driver warning app for drivers and a traffic risk dashboard for traffic managers. These applications deliver real-time alerts and insights, enhancing safety for both drivers and traffic management authorities. Third-party innovation in connected car use cases faces several challenges related to both vehicle and contextual data. Vehicle data challenges. Data sharing. Vehicle data is often not shared or made available by the OEMs, significantly limiting the development and implementation of innovative use cases. Data frequency. Limited data frequency creates challenges for applications that require continuous or high-frequency data streams, negatively impacting their performance and reliability. Real-time data sharing. Latencies and delays hinder the ability to process data in near to real time, which is crucial for applications such as autonomous driving, traffic management, and emergency response system. Lack of anonymized vehicle data. Privacy concerns and stringent data protection regulations like GDPR limit the availability of anonymized vehicle data. Without proper anonymization, sharing sensitive information about vehicle behavior, location, and driver habits becomes difficult despite its potential value. Cost. Obtaining and processing vehicle data can be costly, especially when data providers charge high fees or require significant investments in data storage and infrastructure. This often limits access to organizations without substantial financial resources. Contextual data challenges. Data sharing. Contextual data, such as environmental traffic or infrastructure information, is often not shared by data providers, limiting the potential of vehicle data use cases and hindering the creation of comprehensive, context-aware applications. Costs of data. Even when available, contextual data can be prohibitively expensive for startups and small organizations, creating a barrier to widespread adoption and integration into vehicle-based applications. Analysts have offered varying outlooks for the connected car data market, with projections ranging from $20 billion globally by 2030 to $22 billion by 2029. However, not all players have succeeded in sustaining success in this market over the long term. A 2022 report from Capgemini highlighted that the car is not yet a smartphone on wheels, emphasizing the challenges of creating connected car data services in the same way that apps are developed for smartphones. Additionally, a prominent player in the market, Otonomo, an Israeli car data marketplace, which went public at the $1.3 billion valuation in summer of 2021, reached the end of its journey in 2023. For third parties, the connected car data market has proven to be a challenging landscape. While it was once hailed as the new oil, the exit and bankruptcy of two of the industry's largest players reveal a different reality. Despite having an abundance of product, these companies struggle to sell it quickly enough. Their sales growth fell short of the steep expectations needed to reach go-public valuations or to offset over $250 million in operating expenses. They faced the tough task of disrupting an automotive industry where many companies were not yet ready to share vehicle and driver data. Additionally, territorial disputes over data ownership, along with complex logistical, technological, and business decisions surrounding revenue sharing, added further obstacles to their efforts. While the connected car data market presents challenges, including issues with data sharing and growth expectations, it still holds significant opportunities for third-party innovation. Use cases such as fleet management, usage-based insurance, location-based services, traffic management, car sharing, vehicle maintenance, emergency response, and remote diagnostics offer a promising future for service developers looking to leverage connected vehicles.